Hey everybody, hope you're doing well. This video is going to cap off week 6 in Algebra 1, and for the fourth marking period, this will be the last lesson here of Unit 9, in which we continue to factor and solve quadratic equations. So you're going to notice here at the top, this is going to be very similar to the last video, where we are still factoring completely. We are no longer giving you the strategy off the top here. You have to figure out what strategy or strategies to use to break the problem apart. The only difference for this lesson today is we're going to focus on the solving aspect. So that zero product property, we're going to throw in that equals zero piece and actually go one step further after we factor and solve for x. So a lot of what we're going to do here, again, very similar to all the other lessons. You factor, you solve. You factor, you solve. Same thing here. So very quick review. You can see the chart up at the top. Again, I would have this as a handy reference as we go throughout. We're always looking for a GCF to start. If we have one, great. If we don't have one, great. Once we check for a GCF, we see how many terms we have and then factor it apart from the amount of terms that we have using the appropriate strategy, as you can see listed in the table. So the focus, though, is we are solving these, so we have to factor before we can solve. Remember, when we solve, they must be equal to 0. So we'll see a good chunk of these problems will be equal to 0 off the bat. The ones that aren't, we'll need to make sure to move terms around appropriately before we do the factoring and solving, just like all the other lessons we've gone through. So, number 11, we've got ourselves an expression. It's equal to 0, so that part's at least taken care of. So let's focus on the factoring. First thing I want to check for is there a GCF? Why, yes, there is. I could take a 5 out from the original problem, and I'll be left with x squared plus 6x plus 9. And we'll set that equal to 0. So there was GCF. We have a trinomial, and that is left over. So now we're going to use the trinomial strategy. Multiply to C, add to B. So what two numbers multiply to 9, add to 6? Well, the two numbers that do that are 3 and 3. So this will break apart as 5 times x plus 3 times x plus 3. Now in the last video, once we had it factored apart that far, we stopped. Since there's this equals 0 piece, now we're going one step further, and we're actually solving for x. So, just like all the other strategies, when we did the solving piece, you take the factors, individually set them equal to 0. We're going to do the same thing here. So we have 5, x plus 3, and x plus 3 again. Now, we have 5 equals 0. 5 can never equal 0. So even though I technically wrote that, it's useless. If there's no variable there, I can't solve for it. So don't make the mistake of saying, well, x has to be 0. There is no x in an expression like that, therefore it's pretty much useless. If you see that, you don't even need to write that out. I'm just more showing you that so that you realize, hey, there's a factor in front that also technically can be set equal to 0, but if there's no variable there, useless. So that's why I scribble it out. Now you notice the other two factors I have left over, this is a rarity where they're both the same thing. You don't technically need to solve this twice because you get the same answer for both of them. X is negative 3, x is negative 3. If you write it out where, hey, there's two of them, you can certainly do that, that's fine. If you recognize, well, it's the same factor, I get the same answer, you only technically need to write it once. This is something technically called a double root. It's something that you'll learn more about in Algebra 2. It's not that important right now. But just know, if you get the same factor, get the same answer twice, you didn't do anything wrong. Sometimes that happens. But there you go, that's how you solve it. So we factored the part using the chart from up top, took out the GCF, broke apart the trinomial, take all the factors individually and set them equal to 0. Number 12, same idea. It's equal to 0, so that part's taken care of. It's set up correctly, so now we can go factor. First thing I'm going to look for is a GCF. What do you know? There's a GCF. I can take out a 5x, divide it away from each of the terms. I have x squared minus 5x plus 6, set equal to 0. So again, I got that trinomial in parentheses, so I want to know what multiplies to 6, adds to negative 5. The two numbers that'll do that are negative 2 and negative 3. So you can see how that breaks apart. I now have 5x times x minus 2 times x minus 3 equals 0. That is as far as I can factor these apart. So now I'm going to take each factor, set it equal to 0. So you can see how I'm splitting that apart. Now you'll notice instead of having, like in the last problem where it's 5 equals 0, it's a 5x. The fact that there's an x there means you can solve for this. Divide each side by 5. The first answer is x equals 0. Second problem, you'd add 2, x equals 2. And the last problem, you'd add 3, x equals 3. So we get 3 different answers for this, 0, 2, and 3. Again, since we're doing more factoring, you're going to have more factors, which means you more than likely will have multiple answers. So, you might get a rare case like number 11 here where you only get one singular answer. Problem like number 12 where you get 3 of them. That can happen as well. It just depends on how everything breaks down. So now, there are several more examples on the next slide here. Again, if you have a good handle on how to factor these apart, try to do a couple of them. See if you're getting the same answers I do. If not, obviously follow along. Again, I would make sure to have this chart handy for your reference. All right, so number 13. Okay, it's equal to 0. That part's taken care of. I see 4 terms. Quick look at it. There is no GCF to take out. There is no number I can divide out of all 4 of those terms. They don't all have variables, so there is no GCF I can take out. But since it's 4 terms, that means we are going to employ the grouping strategy. So you notice, group the 4 terms. The equals 0 just hangs off at the end there. Grouping, take the GCF of the first group, x squared, and you're left with 4x minus 7. GCF of the second group is negative 4, which means you're left with positive 4x minus 7 equals 0. I rewrite these factors. X squared minus 4, 4x minus 7 equals 0. Now, remember, we saw this in the last lesson with these grouping problems. Sometimes they can be broken apart further after you've grouped. If I look at the first factor here, that's a perfect example of difference of squares. 2 square rootable terms being subtracted. So I can take x squared minus 4, make it x plus 2, x minus 2. Still have 4x minus 7 equals 0. Now that I factored it completely, now I can go ahead and solve. So I'll get 3 different answers here. I'll get negative 2 after I set the first factor equal to 0. Second factor, I'll get x equals 2. And the third factor, add 7 divided by 4, I get x equals 7/4. If you get an answer that's a fraction, you can leave it as a fraction, you can write it as a decimal, I don't care, as long as it's right. But there's your 3 answers, x equals negative 2, x equals 2, and x equals 7/4. Number 14 there, 2x to the 4th minus 162x squared equals 0. Again, it's equal to 0, so that part is done. Now we're going to take a look at, can I take out a GCF? Absolutely. I can take out a 2x squared, leaving me with x squared minus 81. So, I look at the binomial here that does meet difference of squares. X squared minus 81, if I square root it, I get x and 9. So, added and subtracted, x plus 9, x minus 9. So, I get my factors here. I have 2x squared equals 0, x plus 9 equals 0, x minus 9 equals 0. Now, if you're looking at the first factor going, well, there's a squared there, shouldn't I do more with it? You really don't have to worry about it because all that's being multiplied together. It doesn't matter what math you would do, since it's all one compacted term, there's no plus or minus there. X only can be 0. Because technically what happens is you divide away the 2, and then you'd square root each side to get x by itself. Ultimately, a factor like that, it can be 2x squared, and it can be 10x to the 5th, whatever combination you can think of. If it's just one singular term equal to 0, and there's an x there, x has to be 0 no matter what. Other ones, quick basic math. The second answer would be x equals negative 9, and the third answer would be x equals positive 9. So there are your 3 answers there. Number 15, it's equal to 0. Cool. Let's take out a GCF and look for that. Looks like the biggest thing I can take out here is a negative 5 and be left with positive 16x squared minus 9. So we'll take a look at the binomial here. That does meet difference of squares. If I square root each of those terms, I get 4x and 3. So again, one gets added, one gets subtracted. And there we have my factors. Negative 5 times 4x plus 3 times 4x minus 3 equals 0. Each factor is set equal to 0 again. So here's another example where, again, that GCF that was out front, there is no variable. Negative 5 can never equal 0, so it's irrelevant. I'm just going to scribble it out. The other two, they have x's, so I can solve. This in 4x plus 3 equals 0, I would subtract the 3, divide by 4. X equals negative 3/4. Last one, I'd add 3, divide by 4. X would equal positive 3/4. So in this case, you get two different answers here. And again, that's just because of how the factors worked out and broke apart. All right, last example here, number 16. So you notice in this case, it is not equal to 0. If it's not equal to 0, we need to make it equal to 0 first. Now, a couple ways you could theoretically do this. Again, we talked about when we did these problems with trinomials. We always wanted the x squared to be the positive term. Now you notice, this case, we have a term that's even higher than it in terms of degree. X cubed is a higher degree term. The highest degree term, if we can keep it positive, let's keep it positive because it'll make the factoring a little bit easier. What I'm going to do in this case is I'm going to move the 13x squared, subtract it, and I'm going to add the 36. So I'm going to move everything from the right side to the left. None of these are like terms, so I'm just going to put them all right next to each other. Now that I've done that, now I can go ahead and try to factor this apart. So the first thing I want to do, see if there's a GCF. Now I noticed here one little mistake that I made. We're going to actually put an X with the 36, otherwise this problem's not going to work out the way that I intended, so that's a little typo on my end. My apologies. So once we fix that up, now this will actually work out the way that it's supposed to. At any rate, let's go ahead and take out that x to start, because there is an x in common with each of these. That'll pull it down to x squared minus 13x plus 36. And you'll see why me fixing the problem the way that I just did there is very important, because otherwise this won't factor apart the way that it's supposed to. Okay, so there was a GCF of an x. Okay, so again, we've taken out GCFs that have been just numbers. You can't take out GCFs of just variables. If you go back to the less weeks ago on GCF, we definitely saw some examples of that. Now let's look at the trinomial. Multiply a c, add to b. What multiplies to 36 adds to negative 13. The two values that will do that are negative 4 and negative 9. So that leaves me with x times x minus 4 times x minus 9 equals 0. So I take each factor, now I set it equal to 0, and then we solve. So obviously if x equals 0, that just means x equals 0. There's nothing to do there. Our second answer would be x equals 4, and our final answer would be x equals 9. So again, this is just building off of the last lesson here. It's the same factoring strategies you've been using all unit long. It's just a matter of kind of following that flow chart, recognizing how many terms you have, and using the appropriate strategies to break it down. Again, once you've broken it down, setting the factors equal to 0, very basic algebra. Really, the biggest thing you need to make sure of is not screwing up the signs as part of your final answers after doing all of that work. So it's a tedious process, but again, hopefully you've seen, as we've gone throughout this entire chapter here over the past several weeks, that it all kind of just builds on top of each other, and hopefully you've been able to connect the pieces with that and been able to build things together. Because like I've said, this is something that's going to be a really critical skill as you move into Algebra 2 next year. It's definitely something you'll review a lot at the start of next year, because it is a skill that you use at a lot more upper level math as you work with bigger problems like these. So with this, like everything else, graded assignment that goes with it, it's just a handful of problems here, very similar to these. Again, I highly suggest jotting these down, screenshotting it, whatever, so you can kind of go back and use these as a reference in the model to try to complete the graded assignment. If you are struggling with this, please by all means send me a message on Schoology, shoot me an email, or stop by my office hours on Zoom so I can help you out and make sure you understand what you're doing. We do have a few lessons left after this. There's not that much. They're all still based on factoring, but they're set up a little bit differently. But it's going to use these same factoring strategies as we finish out the rest of the year here. So if you still have questions on how to factor, how to solve these, please make sure you're reaching out to me so we can get things squared away. Otherwise, if you're good to go, thanks for watching. Stay safe, stay healthy, and we'll see you next time.